So I think one of the great things about learning a new concept is how it relates to previous ones. When we first learned addition, for example, we learned its opposite operation, we learned subtraction, right? When you learn multiplication, what do we learn afterwards? When we learned multiplication, what was the next thing we learned after that? Subtraction, was it? The opposite, we learned division, right? We learn one operation, then we learn these kind of opposite things. And it doesn't matter how complicated these things are. What if I learned something like x cubed? What was the opposite of that? Yeah, right. So if you cube something, like what does it mean for something to be the opposite, right? It's like going back to it, right? You add 5, you subtract 5. You multiply by 5, you divide by 5, right? You cube something, you cube root it, right? And that's no different when we're looking at functions. Functions, in some sense, have an opposite as well. There's a more mathematical term. We call it the inverse of a function. The inverse of a function. Someone's looking ahead in their chapters. It's great. These operations here, they are also, in some sense, inverses. What does it mean, though, to take the inverse of a function? Okay, because functions, they're not really operations, right? They're kind of expressions. Let's take a simple function. Let's take y equals to 2x. Right, I want to think, what would be the inverse of something like this? Well, have a think about what this is actually doing, right? If I put in some x value, if I say x is equal to 1, what am I getting out of this? I get y is equal to 2, right? You put something in, you get something out. What the inverse is saying is, how do I go from this back to that? Right? How do I go from 2 back to 1? Well, what would you need to do to go from 2 back to 1? You just have to, think about, again, your kind of operations. Right? You're multiplying by 2. The inverse, as a function, we can also write that. That would just be y equals to half x, right? That's the inverse of that function. We say, all right, well, when I put in x is equal to 2 now, what's my y value? I get 1, right? And that at its heart is what the inverse is. It's saying, I start from something, I get some result. How do I get this and go back to where I started from? All right? Can you guys jot that down for me? The inverse of a function, looking at how do we go back to where we started. What exactly is tricky about it? Or what's different about it? There's two things happening here. Right? There's two things happening. Not only are we multiplying something by 2, but we're adding 4 to it, right? So let's use a value. Give me a value. Easy value to use. 3. Okay, x equals to 3. What happens when I put this into the function? I get 2 times 3, which is 6, plus 4, which is 10. Okay, now, using these kind of ideas of an inverse or opposites, how can I go back? What would I need to do? Okay, so you want to say, take this and halve it, so that gives me 5. No. And then take away 4, do I get back to 3?
Minus 4 divided by 2.
Oh, okay, so we minus 4, that gives me 6, and then divide by 2. Notice that now when you have multiple operations here, the order in which you do this matters, right? Does that make sense, right? Okay, so we kind of have to, we have to go back first. The last thing that we put in there, it's kind of like tying your shoelaces. The last thing that you put in there, you have to kind of untie that operation first, right? So y is equal to, what's the first thing we did? What's the last thing that we did here? We added 4, right? Good, yes. So the first thing you have to do is you take away 4, and then we divide by 2. We're still using the opposites, by the way, but just be careful that actually the order does matter when we have multiple operations there, right? So let's just verify this. X is equal to 10. Let's put it in. 10 minus 4 gives me 6. And divide by 2 does give me 3. Awesome. Yay. What I'm going to get you to do now is, I said there were two things that is happening when we look at the inverse. There's an algebraic and there's a geometric thing. Notice. I didn't really know what a fancy word was. So yeah, there's something that we can notice. See if you can work it out. Plot these two, see what happens. Plot these two, see what happens. Plot these two, See if you can notice anything. I'll get you started, right? Don't say that loud. Okay, so two things happening algebraically and geometrically to obtain the inverse of a function. Just with the first one, okay, the first one, what kind of graph would these give us, by the way? We'd get, what would we get? Some cool straight lines, we do. Now, I'll graph one of these for you. In fact, I won't graph that one because that one's pretty, you can kind of do that yourselves, right? It's just changing gradient, right? No? This one is interesting though, because we haven't really looked at cube roots, but we don't really know what they look like. I'll graph them for you. So this is y equals to x cubed. What is that, by the way? That's a cubic. Boom. Now the y equals the cube root of x, this is going to be pretty cool. I have to bring up this function. Okay, boom.
Whoa.
That's pretty cool. So, I'll leave that up there. I'll leave that up there. Now, the red line is y equals to x cubed. The blue one is y equals to the cube root of x. I'll leave that up there so that you can just have a look at it. Graph the other ones for me. But also, two things you're looking for. What's the kind of algebraic thing that's happening? Because you're going to look for two things for me. You're going to look for an algebraic thing that's happening. You're going to look for a geometric thing that's happening.